Hi, this is Algebra 2, Lesson 33. We're going to talk about major rules of algebra and complex fractions. We're starting on page 151. There are three major rules for algebraic manipulations. First, the same quantity can be added to both sides of an equation without changing the solution of the equation. Number two, every term on both sides of an equation can be multiplied or divided by the same quantity except 0 without changing the solution of the equation. So if we have x plus 2 equals 4, we can use Rule 1 to solve for x. We're going to subtract 2 from both sides. Because we're subtracting it from both sides, we're not changing the solution of the equation. And we end up with x equals 2. If we have x divided by 3 equals 5, we can multiply both sides of the equation by 3 to remove the denominator from this side, but we also have to multiply it to this side. So then x equals 15. The first two rules only work for equations. If we have an expression such as 4 over x plus 5 plus x times y over x, or a over x plus y all over b over x, we can only use the third rule. The third rule states that the denominator and numerator of an expression can be multiplied or divided by the same quantity except 0 without changing the value of the expression. Only the form of the expression is changed. This is called the denominator-numerator rule. So if we have an equation with denominators, we can get rid of all of them by multiplying all the terms by the least common multiple. But we can only do that with equations. If we have an expression with no equal sign, then all we can do is find the lowest common denominator of all the terms and simplify the expression into one term. Okay, so if we have 4 over x plus y plus py over x, there's no equal sign. So this is an expression instead of an equation, and we can find a common denominator and put this into one term, and that's as simplified as we can get this. So if we're supposed to simplify this, we're going to use rule number 3 to find the lowest common denominator. The lowest common denominator of x plus y and x is going to be x times x plus y. So in order to have x times x plus y in this denominator, we're going to multiply the top and bottom by x. In order to have x times x plus y in this denominator, we're going to multiply the top and bottom times x plus y over x plus y. Well, we're going to multiply everything through, and then we can put everything over the same denominator. So we'll have x times x plus y on the bottom, and the top we're going to have 4 times x plus py times x plus y. Okay, and now we're going to simplify this. Remember, if you're in my class, we need to get rid of all of the parentheses. Your book is often only going to get rid of the parentheses in the numerator, and they're going to leave the parentheses in the denominator. If you're in my class, I want you to also get rid of the parentheses in the denominator. Okay? So we'll have 4x plus, this will be pxy plus p squared all over x squared plus xy. And that would be your answer. We can also use the denominator-numerator rule to simplify expressions with complex fractions. So if we have x over x plus y all over b over x, we can simplify this by multiplying both the top and the bottom by the reciprocal of the denominator. So we're going to the reciprocal of this denominator is going to be x over b, and we're going to multiply that times the top and the bottom. That makes the bottom cancel, and we're left with this on the top. And we're going to multiply it, and we get ax over b times x plus y. And of course, we're going to get rid of those parentheses. Ax over bx plus by. Okay, complex fractions. We're going to start working with some more complicated complex fractions now. Think of them as puzzles that we will work on one piece at a time. So here we have simplified x over y plus y over yx all over a over y. So we're going to start, in this case, let's start with the numerator. Before we start multiplying the reciprocal around, let's simplify this numerator. So let's pull it off here, and we'll have, oh sorry, this is a 4. That's a 4, not a y. That will help. So we have x over y plus 4 over yx. Okay, so the common denominator here is going to be yx. So we're going to multiply this one times x over x. And then this one is okay the way it is. So this is going to equal x squared plus 4 over, I'm going to flip those around and make them xy. Okay? Now that we have this, we can put it back together with the a over y. So we'll have x squared plus 4 over xy all over ay, or a over y, sorry. Okay, now we can get rid of the denominator by multiplying the top and bottom by the reciprocal of the bottom here. So we have y over a. So this part cancels. This y is going to cancel here, and that is going to leave us with x squared plus 4 all over ax. Okay. If you hadn't recognized that this y could cancel, we would have had x squared plus 4 over xy times y over a. If you hadn't recognized that this y would cancel, we could have multiplied it through. We would have had y times x squared plus 4 over axy. And this is what we would have had right here. Okay, at this point, before you multiply this through, check to see if there is anything to cancel. Okay? If we had multiplied it through, we would have x squared y plus 4y all over axy. And now we can, because there is a y in every term, we can still cancel this. So you have multiple chances to catch that this y can cancel. Do look for things that can cancel. That's one of the reasons we pull everything out of parentheses. But if before you pull everything out of parentheses, if you check, you save yourself some steps. Okay, so look for things that can cancel. Okay, any way you do it, that's going to be your answer. Here's another one. Simplify a over x plus y plus m over y all over x over a plus m. Okay, once again, our numerator is very complicated, so we're going to pull it out and simplify it and then put it back into the big equation. So we have a over x plus y plus m over y. Okay, so our least common multiple for our denominator is not going to be xy. It will not help us to multiply x to the top and bottom here, because that'll give us xy. And this is x plus y. So our least common multiple for our denominator is going to be y times x plus y. Okay? In order to get y times x plus y over here, we're going to multiply the top and bottom times y. In order to get y times x plus y here, we're going to multiply the top and bottom times x plus y. Okay, so over here we end up with ay, and here we're going to end up with m times x plus y. Okay, let's stop now and see if there's anything that can cancel. There's only an a here, only an m here. There's a y in both of these terms, but remember this y is added, so there's nothing we can cancel at this step. So we're going to go ahead and multiply things through. We'll have ay plus mx plus my all over xy plus y squared. Okay, now that this is simplified, we can go ahead and put it back into our original equation, and this will go back to being our denominator. Okay? Okay, so now in order to get rid of this denominator, we're going to multiply the top and bottom times the reciprocal. I did mention these are going to get more complicated, didn't I? And they certainly are. This is a lot more complicated. Now the top and bottom here cancel, and we are left with ay plus mx plus my times a plus m all over xy plus y squared times x. Alright, let's simplify this mess. So we're going to multiply these terms one at a time to these guys. We're going to distribute it. So we'll have a times ay is a squared y. A times mx is amx. A times my is my. M times ay is my. M times mx is m squared x. M times my is m squared y. And on the bottom, we're going to have x times xy is x squared y. And x times y squared is xy squared. Okay, now we look for common terms. Or like terms, sorry. Now we look for like terms to see if there's anything that can simplify. And we have two Amy's here. So we'll have a squared y plus amx plus 2amy plus m squared x plus m squared y all over x squared y plus xy squared. Isn't that lovely? It is not pretty, but it is correct. Take your time on these. Make sure you're writing out your work so you see where you were last. Pull things out of parentheses and look for like terms so you can put them together. Okay? That is it for this lesson. Try your practice problems and your homework and let me know if you have any questions. Thank you.